This conference will now be recorded.
All right, so let's learn threads today. Okay. So thread provides multitasking capabilities in Java. Java thread is a single path of execution in a program. All the thread shares the available CPUs to perform the task in parallel, providing multitasking capabilities. All right. So what do you guys understand by the term multitasking?
Performing multiple tasks simultaneously.
Right? Like you're driving and you're listening to the music at the same time. Okay. You're typing and you're talking to someone. Okay. You're having your dinner, you're watching your movie, you're having a conversation with your family, all the things happening at the exact same moment. That's what we call multitasking, isn't it?
Yes.
Now, when you do multitasking, is it the same person, that is you, who is doing all that job, or is there a version or a copy of you who is doing multiple tasks individually?
Same person.
Same person. So how does that happen? I mean, how do you manage to do that? Your brain. Okay. Now, truly speaking, multitasking is something when there is one person who is doing more than one job at the exact same time. Okay, that is multitasking. When you put that sentence with reference to computers, computers do multitasking if there are more tasks than the available CPU. Okay, so what you guys need to understand is the brains of any machines are the CPUs. Okay, the CPU that comes with your hardware, that's the brain of your machine, central processing unit. Okay, that hardware is responsible for processing everything on your machine, on your system. Okay, so imagine compare CPU with your brain. Okay, now when you do multiple tasks, it's not that you have like two different copies of yourself who are doing individual tasks at the same time, but your brain is a very powerful machine in itself. Okay, your brain can switch between both the tasks at the exact same time, that you do not feel any difference at all. Okay, you assume that all the things are happening parallelly, but that's not true. Okay, your brain, just like CPUs, is calculating, processing information at a speed of nanosecond. Okay, nanosecond is like how much? How much is 1 nanosecond?
10 power negative 9.
A billionth. Okay, a billionth part of a second is nanosecond. Your brains, and so does the CPU, are capable of calculating information, process information at a speed of a billionth of a second. So imagine this: if your brain is capable of switching between one task for every 1 billion second, would you notice the difference? Would a human eye catch that difference? One billionth of a second. You wouldn't. Okay. Human eyes are capable of perceiving things at a speed of maybe 1/10 of a second. If something flips, if you're watching a screen goes blank for just 1/10 of a second, you can notice that. Okay, that's the best your eyes can do. Okay, but your brain processes information at a speed of like nanosecond or even faster. Brains are even more powerful than CPUs. Okay, the reason you're doing multitasking is what your brain does is it is switching between one task and the another task every 1 billion second. Okay, so you're dedicating 1 billion second, billionth of a second to one task and the next moment to the other task. That gives you the illusion of multitasking. Your brain is not truly doing the multitasking. There is only one brain. Everyone has just one brain. Okay, so if there are two brains, then yes, you would say, one brain is doing this job, another brain is doing that job. That's how we do the multitasking. But that's not true, is it? So you're able to do multitasking. The reason is because your brain is processing information at such a high speed that you wouldn't notice the difference. Your human eyes are not able to notice the difference between both of them. Again, that's what gives you the illusion of multitasking. Okay, so are you really doing a multitasking when you do drive and listen to music? Are you truly doing multitasking, or you're more like switching between both the tasks at a very high speed, giving you that illusion of multitasking?
Illusion.
It's just an illusion. Okay, so you have seen those arts, right? If you move your hand, okay, your hand motions, like when you're saying bye to someone, you might have done that when you were kids, right? If you move your hand at a very fast pace, left to right, at some point, wouldn't you feel that your hand is in both the positions at the exact same time, in the left and right?
Yes.
So does that mean there were two hands, or there was just one hand which was moving at a very fast pace that gave you the illusion of two hands?
Just one hand.
Right? So you get the idea, right? How exactly multitasking happens. You switch between tasks, both the tasks at a very high speed, and that gives you the illusion of multitasking. It's truly not a multitasking. Okay. The system, the machines operate in the exact same way. Okay. Right now, how many softwares do I have open here? I have a PowerPoint. I have Eclipse. I have a Notepad, spreadsheet. I have a GoToMeeting. My speaker is on. My mic phone is on. I'm using internet. My screen is lit. So there are so many tasks running on this machine at the exact same time, right? Look at this. These many programs are running on my machine at any given time. Okay, these are the softwares running on my machine. Okay, so here my system is doing the same job that our brain does. It is switching between each task at a very high pace that I wouldn't notice any difference at all. Okay, I wouldn't notice any difference. For me, this laptop is multitasking. It is running multiple softwares at the same time. I can use spreadsheet, I can use PowerPoint, GoToMeeting, and this thing. Okay, my laptop is right now doing multitasking. The reason is the CPU is switching at a very high pace. Okay, so do you guys understand how multitasking really operates with your personal experience as well as system machine wise?
Yes.
All right, so if you guys want to know what is your CPU, what is your machine configuration, you can always look into this. Okay, you can open task manager, go to performance, and click on CPU. Okay, so right now how many CPUs I have? I have 4 CPUs. Okay, I have 4 CPUs running on this laptop. Okay, that means I have like 4 brains running at the laptop. So on my machine, what would be truly a multitasking? If I'm running 2 jobs on my machine, is that a multitasking? Remember, I have 4 CPUs, or in other words, I have 4 brains that is processing information.
No.
It's not, right? Because if you have 4 people to do 2 jobs, it's not truly a multitasking. One person picks one job, 2% picks the second job. The other 2 are sitting idle. Both CPUs are working on individual job at the same time. Both person are working on individual task at the same time. Okay, that's not truly a multitasking. What if I have 6 jobs on my machine?
Then it's multitasking.
That would be multitasking. Okay, my CPU is 4. So imagine if I have 4 brains or 4 people, and I want 6 jobs to be done at the same time. So the best they can do is 4 people will pick one job at a time, and whatever the 2 additional jobs they have, they will switch it. Okay, they'll just switch it for a minute, for a second. They'll switch between this job and that job for a second. So ideally, if you perform more jobs than the available CPUs, that would be multitasking. If you perform more than one job yourself, that would be multitasking. If you're doing just one thing, that's not a multitasking. Okay, so that's what you need to consider. The number of CPUs on your machine versus how many jobs you're running right now. Okay. All right. So the next thing you guys need to understand is how a traditional program works and how is thread program different. Okay. Right. So I have 3 classes here. Class A and class B. Okay. Now, if you want to call method 1 from here, what would you do? How do we call method 1 from here, line number 6? Anyone?
Create object.
Create an object of class A. And call method 1. Now, how do I call the method 2?
Create object of class.
Create object of that class as well. All right, so just tell me what will it print? Okay. Okay, what is the output? Remember, we did the whole stack trace, how the control goes, and everything. So what will be the output of this program?
Begin.
First,
Class,
it will print begin.
class A.
Then it prints class A.
1.
1.
Class B.
Then class B.
And exit.
And then exit. Okay. So technically, this is what your program does. First, you sys out begin. Now, does everyone understand why it prints like that?
Yes.
Does everyone understand? Okay. All right, so the main program begins. Okay, and the first line you do is print begin. Okay, so first line you do is print begin. Now, after that, you created a class object, class A object, and call the method 1. The moment when you call method 1, the control goes from main program to method 1. Okay, and inside method 1 we are printing class A. Okay, so first it prints begin. When you encounter the method call, the control goes to method 1 and you start processing whatever you have in method 1. Okay, now when you're done with method 1, it returns back to whoever called it. In this case, the main method. You return back and then you continue with the next line. Okay, so here after returning back, you're printing 1. Okay, after that you created class B object and called the method 2. You called class B method 2. There you printed class B and then after when you're done, you return back. Okay, so in method 2 of the class B program, you print class B and then you return. Once you return back to main program and then you exit. Okay, so that's when you exit. So yes, it will print in this order. Print begin, class A, prints 1, prints B, and finally prints exit. Okay, so this is the usual thing. Now this is what we call sequential program. Okay, because there are 3 programs in question: the main program, class A, and class B. Sequential is you go in a sequence. The moment you call the other method, you go out to that method and do not process any further lines. Okay, there is a pause here. So this is where you pause the main program. Okay, multitasking would be doing multiple things at the same time. But here, this is not multitasking. Okay, this is a sequential programming, not a parallel programming. Okay, in a parallel programming, this is how it would look like. All the programs are executing at the exact same line. Okay, if you notice at this particular time slice, aren't all program executing? Aren't they all in yellow? Okay, yellow means it is processing something. This program is processing something. Now in the above sequential program, at any given point, is the yellow cell coinciding with any other program?
No.
No. When the program A is processing, what is program test and class B doing? Nothing and nothing. When the class B is processing, okay, these lines, these are the processing lines. When class B is processing, the main program is doing nothing. It is on pause. And this is also on pause. This is what we call sequential, one after the other. After this method, you go here. After this, only then you come back. Sequential programming. A parallel programming is something where everything is running parallelly at the same time. Okay, they all, if you notice, take this time slice. At this time slice, test is also doing something, class A is also doing something, class B is also doing something. They all are processing parallelly. This is parallel programming. And whatever you guys have done so far, they are all sequential programming. Okay, Thread specializes in parallel programming. Okay, all right, so let's take a print here. Begin, then class A, it went to class A. Only when you came back, then you printed 1, class B, and then exit. Okay, so it's everywhere. When the main program was doing something, other program did not do anything. Class A was processing, the other 2 sits idle. Then the main program, then the B class, and then again the main program. This is sequential programming. Okay, only one thing happens at a time. Only one program is doing the job at any given point. Okay, now here, if you convert this into, okay, so you guys got the sequential program output here, right?
Yeah.
Okay. Okay, so if you want to write a thread program, you have to extend the class Okay, extend the class thread. Extends thread tells you that this program is not supposed to be processed sequentially. This program will be processed parallelly. Okay, when this program is running this line, the main program doesn't have to wait. Okay, just like this. When this is being executed, when you're executing these lines, the other program does not have to pause. They can continue with the next line, printing 1. That's what it means. Okay, so to explain Java, the runtime Java environment, that this is a special program and the other program doesn't have to wait until this completes, then you declare this class and this class as extends thread. Okay, when you extend a thread, this program has a special privilege. Okay? Now, just like the main program always has the signature public static void main, right? The thread program has a similar method. Okay, and that signature is public void run. Okay, so you remember, if main public static void main is the main entry point for this program, for a thread program, the main entry point is public void run. Okay, okay, and you say start whenever you want to start this program parallelly. You say start method. Okay, so remember, do you see any start method here? I created an object of class A and I'm calling the start method. Do you see any start method here?
No.
No. So where is the start method?
It's in thread, I guess.
Yes. Okay. Since you're extending thread class, you did inherit one method from thread class, which is start. Okay. Start is a method call which indicates this program can begin. Okay. Now, usually what you guys remember is in any application, there is only one main method, public static void main. But here, think about this also like a main method. Okay, public void run should be treated as a main method. It's a main method for parallel programming. Okay, so this is a traditionally sequential programming entry point. The public void run method is a starting or entry point for a parallel programming. Okay, if you want this program to run parallelly beside this program, what do? You write the signature public void run. Okay, so what I'm going to do is I'm going to endless print main method. Okay, in main method, I'm going to endlessly print in main method here. Okay, I'm going to endlessly print in class A method, and here I'm going to print in class B method. Okay, I can just write this. Okay, let me make this as a sequential program and you'll see the difference. Okay, this is a sequential program. Now, what will be the output?
In class A method, in class B method, and in class main.
This is an infinite loop.
So it will
This is an infinite loop.
So it will be just
so what
on
will happen after? Yes.
It will
You create an object of class A and call the M1 method. the control goes to M1. When you're here, you're endlessly printing class A method. Will you ever get a chance to return back to this line?
No.
It's an endless loop, so you'll never come back. So the only output you'll see is this. You're endlessly printing class A method. Okay, you're endlessly printing class A because this is a sequential programming. Okay, you never came back and called method 2, which is also printing endlessly class B method. You never got a chance to print main method endless loop either. Once you gave control to M1 method, you were stuck right here. In a sequential program, only when you return from this method, then you can continue with the next line, isn't it? So are we returning from this program?
No.
No. So you're stuck here. As long as you wait, it will just print class A method. That is your sequential program. Now, let's convert that into a thread program. Okay, you have a thread program. So what is the main entry point for a parallel programming thread class?
Run.
Run. So just like public static void main is the main entry point for this program, for a thread program, the entry point method signature is public void run. Similarly, public void run. Okay, so now, as you notice, in a sequential program, there is always one exit and one entry point. What are they? It starts from the program which has the main method. And where does it end? Where does the program end?
From the
The
main
same main method.
The same class which has the main method. Okay, it ends in the main method itself. So in a sequential programming, since there is only one path of execution, okay, sequential program has single path of execution. Okay, there is only one path. You go like this, you take a detour, it's temporary. You come back, detour, come back, but you exit from the same program. Okay, there is a single path of execution, sequential programming. In a parallel programming, is it a single path of execution?
No.
No. Every program has its own entry and exit point. Okay, every program has its own entry and exit point. For the test program, the entry point is main method, and you exit when the main method is over. For the class A, the entry point is which method?
Run.
Run. And when does it exit?
When the run method finishes or exits.
Yes, exactly. Okay, just like the main method, when you're done with the main method, your program exits. Similarly, in these two classes as well, when the run method ends, your thread, your program also exits. So here, there's only one exit point because this is a single path of execution. In parallel programming, if this is a thread and this is a thread, you literally have three programs or three threads. The main thread and the other two threads. They all are running at its own pace parallelly, and they all have their own exit, unlike the sequential programming. Okay, now let's look at the output here. All right, so run method is like the public static void main of your thread class. To begin this program in a separate thread, okay, to let this program run parallelly, what you need to call here is start. Start is a method of thread class which indicates the Java runtime environment, JRE or JVM, that this program should be executed parallelly at its own pace. Okay. So the start method is basically like an indication that from this point onwards, this will take a parallel programming. If you call the run method, this will be a sequential programming. Okay, it will call the run method, come back, and then continue. But if you say start, your program will become parallel programming. So when you say start, this method will be running at the same time when the main method is also running. Okay, that's the difference between start and run. Right, so now let's see the output. Now, last time all we could see is class A print. Now, do you see just class A or do you see all three?
All three.
Okay, you have class B prints, you have class A prints, you have main method prints. Okay, you see all the output. So what does that mean? This is a parallel program. All the programs were running parallelly. Okay, now if I call run instead of start, this would be a sequential. Okay, start method is the one indication that this program should be running in parallel mode. If I just call run, just because the method is called run, if you call run method, this is not a parallel programming. This will turn into a routine sequential programming. Look at the output. Is there any main method or class B this time?
No.
No. So this was treated like any other method, a sequential program. So start method is the one method which actually runs the other program in a separate thread parallelly, not sequentially. If you call run method, this will be just like any other method, public void method 1, method 2, like that. So when you run the program in a sequential mode, you are stuck in this infinite loop. Until you get back from this method, you will never be able to continue with the next class or the while loop. You will be stuck in this infinite loop. Okay, so do not call run. If you want to start parallel programming, parallel thread, you say start. Start is a method which is inherited from the thread class. That's a special method which actually makes your program parallel. Okay, so now you have a mix of everything. You have main method prints, you have class A, you have class B, it's all mixed. Okay, everything, all three programs are running at the exact same time, parallelly. Okay, this is parallel programming. Okay, so this thread is infinitely printing and so does this, and so does this. All three threads are infinitely printing on its own. Okay, so you guys understand what is parallel programming and sequential and how to write a thread class?
Yes, but where it is used, like in programming example.
All right, so let's see practical application. Every software that you might have heard of, they are all parallel programming. Okay, your cell phone, if you launch WhatsApp, does that mean your other applications won't run? You won't be able to receive calls?
Yes.
Is it? That's a parallel programming.
Okay.
Okay. Now, all the softwares that you see, okay, all the softwares that you see, they are all parallel programming. If you do multiple tasks at the same time. Okay. Now, take this thing, take your websites. A sequential programming is you write a program and one customer visits your website. If it was a sequential program, what will happen? If there are 1,000 customers logged into your website, they're trying to order something online. If your website was a sequential programming, what would happen?
It will let one customer at a time.
Yes. Okay, one customer at a time. One customer will browse for 1 hour and pick something and place the order. When they are done, only then you can entertain the second customer. Website itself is a classic example of multi-threading right there. Okay, because at any given point, millions and millions of customers are logged into Amazon, Facebook. They are uploading, they are downloading, they are commenting, liking. They all are doing that at the exact same time. That itself is multi-threading. Okay, because your one program, your one website software is engaging thousands of people at the same time, millions of people at the same time. Okay. Now, thankfully, when you come to the website server, the website programming is a very, very complex thing. Okay, it requires tremendous amount of thread programming. The good part is you don't have to write any code, thread related code, to make that website multi-threaded. When you install the software, the JDK software, when you install all the softwares needed for your website, it usually has a thread program already inbuilt. Okay, it is like a JDK library. It is already there inbuilt, so you don't have to write any code at all for the website part of thread multi-threading. Okay, so you might be worried, how do I handle millions of customers on my website at the same time? How can I write a thread program, such a complex thread program that is capable of engaging millions of customers parallelly at the same time? If you're worried about that, the good thing about this is when we go to website development, you will notice that we will install certain softwares that will come inbuilt for that exact role, the multi-threading role. Okay, so nothing to worry about that. This is at a much lower scale. Okay, if you want to just keep 2 or 3 programs engaged, then you can use the thread programs. Okay, if you want to coordinate 2 or 3 programs to run parallelly at the same time, then yes, you have to worry about all that. Okay.
Yes, sir.
All right. Now, okay, so physical core, logical core, CPU, you already saw that. Most of the laptops already come with multiple cores. Okay, so you might have heard about these terms, dual core, quad core, and so on. Have you heard that?
Yes.
So dual core is 2 CPUs, dual, and quad core is 4 CPUs, quad. Okay, so you have dual core, quad core, and so on. Okay, so every laptop when you buy, you'll hear these terms. So what they are telling you is how many CPUs you have in your laptop. I actually have dual core, but they have logically split that into 2 more. So total, I have 4 CPUs. Okay. Now, let me show you this priority example. Okay, just like the previous program, infinity loop, I have a program, thread program, okay, which has the run method in it. Okay, this is the main entry point for a parallel programming class, this class. Okay, so as you see, this is also an infinite loop, isn't it? While true. Okay, so while true, meaning this is an infinite loop. So I'm just trying to show you how powerful your CPUs are. Okay, now here what I'm doing is I'm incrementing the I variable, and every time the I variable is incremented 10 billion times, I'm printing this statement. Okay, I'm showing you how fast your CPUs can count to 10 billion. How long it takes to count 10 billion is what this program will do. Okay, so let's start with only one thread. Okay, we'll start with only one thread. Okay, so there is one object of this class, priority counter, and if you guys recall, what is the start method doing?
Initiating.
Programming.
It is starting this program parallelly. in a separate thread. This indicates that the main program doesn't have to wait until you come back from this method. You can continue with your next lines and next lines. Okay, you can continue with your other lines. Okay, so technically, if it was a sequential program, the moment you go to the other class, you're stuck here in the infinite loop. Okay, and you'll never print main thread ends now. Okay, so here, let's start this program. So we have a test thread and we have a priority counter. We have two programs. Right, so if you notice, the main thread already ended. Okay, now every time when you reach the last line of the main method, okay, when you reach the last line of the main method, didn't this go away? Didn't your program terminate?
Yes.
Yeah.
But this
Just the
time,
main
even though
terminal.
you reached the very last line of main method, your program is still running because the other thread that you started is still running. Okay, the other thread that you started is still running. That's why the program is still on. Your application is still on. Even though the main program exited, your program is still running because the other thread is still busy counting to 10 billion. All right, so let's see how fast it calculates. The program started at 6:58:17 second and 6:58:54 second. Okay, it took about 37 seconds, less than a minute. Okay, this program took less than 1 minute to count up to 10 billion. So can you understand how fast your CPUs are really? Okay, it takes less than 1 minute to count up to 10 billion. All the while, when other programs are still running. Okay, there are a lot of other softwares running that your laptop, your computer, your CPU is engaged with. Your CPU is still juggling with other tasks, like keeping the PowerPoint up and running, keeping the GoToMeeting running, keeping the spreadsheet running. It's running all the software. Along with that, it is also managing to count 10 billion in less than 1 minute. That's how powerful CPUs are. Okay. Right, so that's what this program does. All it does is it will increment the variable I. Okay, it will increment the variable I, and this modulus is nothing but reminder. If you divide the I variable with 10 billion, and if you get 0 as the reminder, meaning you have done with counting up to 10 billion. That's all it is doing. Every time it is incrementing the I variable and then checking if the count is 10 billion or not. So this is still a lot of processing, but it does that in a really, really high speed. Okay, it basically processed this loop 10 billion times in less than 1 minute. Okay, now let's look at something interesting. Okay, so this time what I will do is I created two objects of the thread class. Okay, I created two objects of this thread. So when you create two different objects or two copies of this class, and start them. So now both these copies, A and B, both these objects, they both will start counting to 10 billion at the exact same time. They both will be counting. Okay. Okay, thread 1 started and thread 2 started. Okay, I named them. This class, I named it thread 1. This class, I named it thread 2. Okay, objects, I mean, the variable A object is named thread 1, variable B is named thread 2. When you say start on each of the objects, basically they both go into this infinite loop of counting up to 10 billion. Now look at how fast they both count. Okay, how soon they count to 10 billion. So here is the question. Did both the program count to 10 billion at the exact same second?
Yes.
So why did they have, I mean, why didn't they finish sooner or later? Why did they finish at the exact same time?
Because it's parallel.
Because,
They are running parallelly.
yes, they're running parallelly. And at the same time, was there any competition for the CPU? How many CPUs do I have?
4.
I have 4 CPUs. And there are 2 threads counting to 10 billion. So is there any competition for CPU time really?
No.
No. If there is no competition, if both of them don't seek any attention from CPUs, there is no competition, then they both enjoy full 100% time of each CPUs. So if 2 CPUs out of 4 have dedicated their complete time for each one of them. And that's why there was no competition. Okay, so they both finished at the exact same second. But now, if I have 6 objects, okay, if I have 6 objects and all of them are non-stop counting to 10 billion, what will be the output now? Will they all finish counting to 10 billion at the exact same time?
No.
No. Why not?
Now they will be fighting for the CPU time.
Exactly. Okay, that's what the waiting period is. Okay, so imagine this. You go to a DMV and there are hundreds of people standing in the line. Why are they standing in the waiting queue?
There's not enough customer representative.
Exactly. Because there are a handful of customer reps. There are a handful of counters. There are 3 or 4 counters and there are 100 people standing in the line. So 100 job to be done by 3 representatives. So what happens? They pile up. When if there are 4 representatives at any given point, only 4 job can be done. What will be the remaining 96 doing?
Waiting
Wait.
for the
Waiting for their turn, isn't it? So now I have 4 CPUs. Think about representative who process your DMV application like a CPU. And think of these 6 objects that are counting to 10 billion as the DMV applicants. At any given point, there can be only 4 customers handled by my CPU. Okay, the remaining 2 will be on hold. Okay, so just like how your brain does multitasking, this is how it would operate traditionally. Okay, so you have like 4 CPUs here. Okay, there are CPU 1, then CPU 2, 3, and CPU 4. Okay, there are 4 CPUs, and the jobs are 6. There are 6 jobs which are counting to 10 billion. Okay, now 2 of them will be in the waiting queue. Okay, these are in waiting queue. So this is how the job processes. Okay, so the first job is being handled by CPU 1. second by CPU2, by CPU3, by CPU4. Okay, I have 4 CPUs in my laptop, but I started 6 jobs. Okay, I started 6 jobs, and they are all counting to 10 billion. Okay, so what here now happens is the job 1 will get about a fraction of a second. Okay, maybe 1 or 2 seconds, let's say. So within that 1 or 2 seconds, job 1 will end up counting to 1 to, let's say, 5 billion. Okay, now they all counted to 1 to 5 billion. So what happens is CPU 1 is not completely dedicated for one job. Just like your brain, you switch between jobs to give that multi-threading illusion, right? So CPU 1 will give certain amount of time to job 1. In that time frame, whatever number you calculated, it remains. So once you have done with this, at stage 2, it will switch the job. Okay, the job 1 goes to the queue, and job 5 get its turn for CPU 1. Okay, now CPU 1 will start helping job 5 to count to 10 billion. So it keeps counting. Okay, it keeps counting. Okay, at the same time, CPU 2 will think, I have given enough time for job 2, let me take over the other job in the queue. So now you put this person back in the line and pick job 6. So CPU 2 will now help job 6 count to 10 billion. Okay, now CPU 3 will think, okay, I have given enough job for the job 3. So what does it do? It puts this job back of the line and picks the one which is on the top, waiting for longer. Okay, now that it picks up here, it will start counting from 5 billion to whatever billion number it is. Okay, similarly, it will pick job 4, and the next one in the line will start processing here. So do you see how it switches job? Do you guys understand how it switches jobs and make sure that every program gets little bit of attention?
Yes.
Okay. All right, so this job switching will come at a cost, because at some point, some program will end up staying in the waiting queue longer. If one program stays in the waiting queue longer, it will be the last thread to count 10 billion. This will be the slowest of all, because job 3 ended up sitting in the waiting room for longer. If job 2 was had least amount of time in the waiting room, this will be the fastest one. This will end up finishing or counting to fastest one. Okay, now if there are more jobs, the CPU has to switch between the live job. Okay, so these are all live jobs. Okay, so these are live jobs and these are waiting jobs. So every CPU has to give a certain amount of time, okay, a fixed amount of time. So let's say it has random timing, like it will dedicate maybe half a second for job 5, and then it will switch over to whatever is waiting in the queue, job 3. And then after job 3 has like half second of time with CPU 1, it will again push it back to the back of the queue and pick the next highest one, job 4. So this goes on forever, and you will find this as your illusion, multitasking illusion. Okay? Just because you have 6 jobs doesn't mean you have 6 CPUs. You always will have 4 CPUs. Your CPUs will switch the job. Okay, it will pick the job 3 and push this one back of the queue. So these jobs will not end up waiting here endlessly, is what I'm saying. Okay, job 3 and 4 will get its turn whenever the CPU switches the job. Okay, job 3 and 4 will get its turn whenever it is done with a specific amount of time with the current job. So every CPU will switch between the live job and the waiting job quite often. Okay, that gives you that illusion of multi-threading. Okay, so you guys follow what exactly happens when you have more jobs than the number of CPUs?
Yes, sir.
Okay. So that's the reason, since it is not an equal amount of time to every job, there will be some, favoritism with one thread, and other will be lacking some interest. Okay, so you will end up that one thread will be more favorable and other thread won't be, and that will result in this output. Okay, all threads are calculating to 10 billion, but here is the thing: not all the thread will finish at the exact same second like what we saw last time. Last time we started 2 threads and both of them finished counting 10 billion at the exact same second. This time it won't happen. The reason is there is a fierce competition of the CPU time. Now look at how busy my CPU is. There are 6 jobs and all the 4 CPUs are at 100% utilization. My CPU is really going crazy because they have more to handle. Okay, 99% utilization. All right, so let's see who finishes the fastest. Remember, this is randomly picked. Okay, thread 1 and 2 are the lucky ones, but still not at the exact same time. 3, 4, 5, 6, not very lucky. Okay, and this is randomly happening. Okay, this is randomly happening. However, CPU will randomly decide I will spend half a second with this. CPU 2 will decide I will spend 1/3 of a second, or maybe 2 seconds. CPU has to constantly switch between the active job and the waiting job, process everything parallelly, and that switching is randomly happening, and that CPU time is randomly picked, and that's the reason none of them have the same amount of finishing time. Okay, so see, we started in this order 1, 2, 3, 4, 5, 6, but they are finishing in some random orders 1, 2, then 5, 6, then 3, 4, and the timing is also quite different. There is a 15-second, 16-second difference between the best performing thread and the worst performing thread. Okay, so you guys understand, right, why this finished at different times versus the previous example? Yes?
Yes, sir.
Now, think about mission critical softwares, okay, like your rocket systems. Okay? Now, if you launch something in the rocket, in the space, right, there is a super computer operating your entire rocket software. Okay, now there are so many things that the rocket software has to manage. Okay, it has to make sure your propulsion is working, your exhaustion, the whole fuel tank, that thing has to work. You can't make your engine run idle, okay, because you are in space, of course. Then again, there should be life support system, right? The astronauts who are on the rocket, they need to be able to breathe and all that. Okay, so life support is also mandatory. Okay, then there are other things as well. There is entertainment. Okay, you can watch some television, you can eat food, you can drink water, and you can take a bath, you can sleep, dormitory. Okay, so there are so many softwares running that is managing your entire ecosystem in the space. Now, if you have to give priority, which one would be the number one? You would make sure that it always gets the attention from your rocket CPU.
Oxygen.
Life support system, yes, oxygen, and the engine, right? the engine and the life support system should be priority. Is it okay if you low priority for, let's say, taking a bath or watching television or sleeping? It's okay, right? You will live if you don't sleep for maybe 5 hours. You will still live if you do not take a bath for a month. But without oxygen, how long you'll last? Without the engines working, how long you'll survive in the space? So that begs the question, if CPUs are randomly giving time to every job, we cannot predict, okay, which one will get more attention from each CPU, which job is getting more priority from CPU. We don't know that because CPU is randomly picking any job it wants. So now there is a special privilege for that thing. Okay, if you imagine that this is a life support job. Okay, this particular thread is meant for supporting life on your rocket system. So what you can do is you can say, I want to give maximum priority for the job which is responsible for life support. Okay, when you do this maximum priority, then this is the thread, this is a job that will get the maximum attention from each of the CPUs. And you will notice that this is the only job that will finish counting to 10 billion the fastest among everyone else. Okay, so this is how you can give priority. Which software or which program needs the highest priority? Okay, let's run this program again. And this time, okay, so we have the life support job running. Then we have the other 5 threads, thread 1, 2, 4, 5, 6. So since we gave this as the priority, life support job will be the first one to finish 10 billion for sure, guaranteed, because that one will get the maximum focus, maximum attention from your CPU. Already done. Now the other 5 threads are fighting for CPU time. They will randomly be assigned. They'll get random time from CPUs. Okay. The life support thread is by far leading with the maximum lead. The life support already calculated 20 billion. Other threads are not even close to 10 billion. Okay, they will get their chance. Just because you say maximum priority, it doesn't mean other thread will never get a chance. They will get a chance, but they have to fight for the CPU time with the other remaining threads. Okay, so this already calculated to 30 billion. Thread 1 to just finished now calculating 10 billion. Okay, because the other thread are also running, but they will get less amount of attention from each of the CPUs. Okay, so you guys get the idea, right? How to prioritize which thread and what. Okay, based on how critical it is, you can decide which one you want to give maximum priority and which one you want to give minimum priority. Okay, that way each of these threads will be treated according to their criticality. Okay, so this is a method. Set priority is the method. You don't see set priority in this class, do you? So where is the set priority method coming from?
Thread, I guess.
From the parent class, thread. The thread program program has the set priority method. Just like the start method, the set priority is inherited by the thread program, from thread program. Okay. So this is how you can prioritize. This is how you can create objects. Okay. You have to create the object of the thread program and call the start method to begin this thread or program in a parallel thread. Okay. If you want to give any, if you're running multiple threads and there is a lot of competition with the CPU, you can decide which program gets more preference by just saying set priority max. Okay. You can also do minimum priority. Okay. If you do not write this, basically all the thread will run at equal priority, meaning medium. They all will run with medium priority, normal priority. Okay. If you want to prioritize, then you can say for the job C, I want to give maximum priority. Okay.
I have a question.
Yes.
Don't we have any method for first in, first out?
Like I said, CPU picks the job from a random time allocation and the switching algorithm. Okay. So there is no priority. So if you're talking about first in, first out, then CPU has to dedicate equal amount of time to every thread, and they have to pick the jobs in the right order. Okay, that would guarantee that everyone gets first in, first out output. Okay, but CPU is randomly assigning some CPU time, and that makes it unpredictable, and that makes it not a first in, first out output.
Okay.
Okay.
This conference will now be recorded.
All right, so there's one more thing you guys need to remember. Extend thread is one way to create a thread program. Okay, but this gives us with a new problem. Okay, what if this program is already a subclass of another program, but it still needs all the features of a thread or a parallel programming? Okay, if this class was already extending something, okay, like class A, it is already extending from class A, and it also wants to be a parallel programming or a thread programming. So what is the challenge here? To be a thread program, you need to extend thread class. So this class is already extending another program. What is the challenge?
We can inherit from two classes.
Exactly. So Java prohibits inheriting from two classes. So you cannot, a subclass cannot be a, if this is a subclass, you cannot extend thread class as well. Okay, since you cannot extend thread class as well, now you don't have that thread capabilities. Okay, so what we do here in case of like this scenario is instead of extending thread class, what we say is implements runnable. Okay, so you are allowed to extend a class and implement another interface. This is allowed. Okay, but you're not allowed to extend two different classes. So when you do like this, implements runnable, this also becomes a thread program now. Okay, so you can extend a thread class or you can implement runnable. There are two ways to do that. Okay, you can extend, you can either extend thread class or you can say implements runnable. Both are fine. Either way, this program will be now a parallel program or a thread program. Okay, and the reason they introduced implements runnable is because if your class is already extending another class, now you cannot inherit from thread class as well. Okay, that was the reason. So here is a slight change that you need to do. If you're implementing a runnable class, this is what you do. Create a thread object and pass your runnable interface implementing class in here. Okay, and then say d.start. This is the only difference. If you want to start a thread class which is implementing runnable, okay, if you want to start a thread class which is implementing runnable and not extending thread class, in that case, this is how you start a thread program. Okay, you have to create a thread object which takes a reference variable a of priority counter, which implements runnable. Okay, so this is the way to start a thread program which is implementing runnable. And this is how you start a program which extends thread class. Okay, this is for starting a thread class which extends thread, and this is for starting a thread class which implements runnable. Slight difference. You need to add one more line in the middle. Okay, two ways to convert your program into thread class. All right, so let's look at the life cycle of a thread program. New is the stage of a thread life cycle where you recently created the object. Okay, when you create an object of your thread program, you will be in the stage called new. Okay, so this is when your thread went into the new stage. Okay, a newly created stage. When you call the start method, your program, your thread goes in a stage called runnable. Okay, your program goes in a stage called runnable, meaning it is running. A.start meaning this program is now running, runnable stage. Now, terminated stage is when you reach the end of the run method. Okay, if you're done executing every line in the run method, your thread will be terminated. Okay, just like the main method. When you reach the end of the line in the main method, your program terminates, right? Similarly, when you reach the end of the run method in a thread class, your thread program terminates. Okay, that is terminated stage. Now there are two more stages in the middle, timed waiting and waiting. Let's have a look at that. So timed waiting is a fixed interval, whereas waiting is an unknown time, unknown waiting. Okay, let's take this with an example. Now when you go to a store, okay, you go to a electronic store or a grocery store or something, and you place an order for an iPhone X. Okay, there are two ways you can get the order. Okay, if they don't have the phone right then in their stores, what would be their response to you?
Time waiting.
Timed waiting or waiting, both can be a possible response from the store owner. Let's see how is that. Either the store owner will tell you, come back tomorrow at 5 p.m. and I will have your iPhone X ready. So is that a timed waiting? They gave you exact time when you need to come back and pick your order.
Yes.
The other kind of wait is the store owner will tell you, I'm not sure when we will get the iPhone X shipment. So whenever I get the iPhone X shipment, I will give you a call and only then you come over and pick your order. So is there any specific time in the second response?
No.
No. That's what these two are here. Time waiting is when they give you the time, saying come at tomorrow 5 p.m. and you'll have your order. The other waiting is we are not sure when the shipment will come in. So whenever the shipment comes in, I'll give you a call and you come back. So it could be tomorrow, maybe day after tomorrow, or maybe the day after that. We don't know how long will it take. That is the second kind of waiting, unknown. Okay, so these two are the different stages as well in the thread program. Let's see how is that. For a timed waiting, there are methods like sleep or join. Okay, let's see how you do that. All right, so this is the method sleep. Okay, sleep is the method that will allow you to go in a timed waiting. Okay, now here I can convert this class into a simple timed waiting. Sleep for 5,000 milliseconds. So what is the conversion between millisecond and a second?
60.
How many milliseconds equals to 1 second? 1,000. 1,000 millisecond is equal to 1 second. So what is 5,000 millisecond?
5 seconds.
5 seconds. Okay, so what I'm going to do is I'm going to put this program, the class A, in a sleep mode. Okay, sleep meaning wait, timed waiting. It will just sit idle for the next 5 seconds and then it will print by. This thread will be in a timed waiting now. Okay, now there is an error. Unhandled exception, interrupted exception. So what kind of exception is this? Is it a compile time or a runtime?
Compile time.
Compile time. Checked. It is a checked exception or a compile time exception. Whenever you have compile time exception, you have to take action right then. All right, so this interrupted exception is when this program is in an idle mode, if other thread tries to wake up this program or interrupt, there will be an exception, interrupted exception. When it is idle, sitting idle, if someone interferes, you'll get interrupted exception. So the Java program requires you to handle that. Okay, it's a checked or a compile time exception. Okay, I'll start class A, and you will see that there is a small waiting period of 5 seconds. Prints hi, it is waiting 5 seconds, then prints by. Okay, between hi and by there was a 5 second gap. So that is what we call timed waiting. You wait for 5 seconds and then you move on. Okay, now the unknown waiting requires two parts, wait and notify, just like the store owner and the customer. When the customer is in a wait mode, when will customer go into action? Like when will they start going towards picking up their order?
On
Yeah, we
the
are notified the order has arrived in the store.
Hence the name notify. When the store owner notifies the customer saying your shipment is in, you can come over and pick up your order. The other person has to notify. Only then you resume your action. That is going to the store, picking your order. So this requires two parts. Wait. Customer will wait until the other program notifies you. Okay, that's what wait and notify combination goes. For a timed waiting, there is no one to notify. Okay, you don't, if the store owner tells you that come tomorrow at 5 p.m. and pick your order, do you still wait for him to notify or call you?
No.
You don't. You just, when the time is up, you just walk there, pick your order. So there is no need to notify or anything. But in this unknown waiting, if you're in a wait mode, you have to wait as long as it takes until the other thread or other program notifies you. Okay, so this waiting requires two actions. You wait endlessly until the other person notifies you. The timed waiting doesn't require that. You just wait for a specific time. When the time is up, you go back to your work, pick up the order. Okay, now wait and notify example is well explained with our next thing, synchronization. Now you will see what synchronization is. Okay, all right, so let's, okay, all right, so did you guys get the different stages of thread lifecycle? Any questions in this?
No.
Okay, all right, so let's look at the synchronization now. Now, this is well explained by the example of producer and consumer. There has to be a specific balance between both the sides, or you will run into a lot of issues. Okay, there is a producer and there is a consumer. They both share the same stock. Okay, they both share the same stock. Okay, producer's job is to do what with the stock? Producer,
Produce.
it produces. Okay, so if you have an inventory here, okay, you have 10 iPhones. Producer job is to produce. So if the producer produces additional 5 iPhones, what will happen? Inventory goes up by 5. The producer produces 10 more iPhones. What will happen to the inventory? 25. Now the consumer orders 3 iPhones. What will happen?
22.
Inventory goes down.
Inventory goes down. So these two thread, producer thread and consumer thread, these two programs, they have to share the same stock object, isn't it?
Yes.
Because whenever they make changes, we want the other person to notify that or to reflect that. If they both have the same stock object between them, then whatever changes this producer does, the consumer can also see that change. Okay, so there are two thread programs, a producer program and a consumer program. They both are going to make changes to this shared object. Now, going back to our reference class, do you guys remember how two programs can share the same object? Class P for producer, class C for consumer, class I for inventory. Okay, here I have the stock as 10. The class program also need access to the inventory. Okay, so I initialize that here. Now, when you order something, how will you make modification to stock? If someone orders 5, how do you modify this variable?
Decreases.
Inventory dot s equals to s
minus quantity.
minus quantity. New stock consumer can see is inventory dot s. Okay, now in case of producer, what will be the code here? When producer produces, what happens?
Plus quantity.
Plus quantity. So what I want you to show is sharing objects, how it is done, and what happens if you don't share it properly. Okay, as per this design, we want producer and consumer to make changes to this object stock. Okay, whatever changes the producer does, if producer adds 10 quantity, consumer should be able to see that latest quantity as well. Okay, so let's see if that can happen first. I create the producer object, I create the consumer object, and I will call p.produce ten, and then c.order 5. So the default stock is 10. Producer produces another 10. What will be the new stock?
20.
Consumer orders 5. What will be the new stock?
15.
15. So ideally, producer should see as 20, and consumer, when they consume 5, it should see as 15. Did consumer see it as 15?
No.
It didn't. So let's see what the problem is. Producer object has an inventory class. Consumer class also has inventory. Okay, so let's do that in the memory. Again, this is the basic questions of how objects are created in the memory. We went through that every single day. So I hope you guys will remember that now.
Won't it be a diamond problem? Like
For diamond problem, need inheritance. Is there any inheritance with any class here?
No. Okay.
All right, so when you initialize the reference variable prod, what happens in the memory?
New object is created for prod.
For prod, an object is created. Here is the question, what is inside prod?
Null.
What does prod class contain? What does it have? Don't you need variables here?
You did.
So what is the variable in P class?
Inventory.
Inventory.
I is the class, inventory is the variable.
Yeah, inventory.
You have inventory. Now, do I have any value here?
No.
Look at the P program, look at the class P and tell
10.
me what will be the value.
10. New.
New. I
If
so
you new I, what will happen when you say new I? I inventory equals new I. What does that mean?
so
Create an
new
object.
object is created again for your
New object
inventory.
is created of what?
Inventory.
Of the I class. I
I.
say new I, so it is the I class object. Now the I class object is created at location 222. What is the I object contents?
Integer.
Integer s. And what is the value of s?
10.
10. So here inventory, this variable will be pointing to what?
222.
Yes. That's what happens in the memory when you create the prod object. You go recursively. Prod is pointing to 111. Inside the prod class, we have another new reference variable here. I inventory equals new I. So we have to create another object for the I variable, I class, and point that reference. So prod is pointing to -1 #111. Inside that location, we have inventory, which is pointing to #222. Okay, that's what happens when you create an object of the prod object, prod class. Similarly, what happens with this C consumer equals new C?
Object created for C with new reference.
This object has what?
Inventory. Inventory is the reference.
Class C's content is?
Inventory. With
There is another inventory with
new
another new
inventory
I.
object.
There are two new operators in prod and class, both. So you ended up creating two different objects, like this one. The C class is pointing to its own copy, and the P class is pointing to its own copy. Now, when the producer produces 10, you're basically saying, in the producer object, from inventory, get me the stock and add 10 to that. So, where will you end up changing to 20?
2 to 2.
20. The same thing goes for consumer. When the consumer says, I want to order 5, the number 5 is deducted from its own copy of inventory. So where does it update to 5?
4,
4,
4.
4, 4.
So consumer sees the stock as 5, whereas the producer sees the stock as 20. Don't they both have to see the same stock?
Yes.
Yes.
It didn't happen because consumer has its own copy of inventory object and producer has its own copy of inventory object. They both have their own inventory objects here. Are they sharing the same copy among them?
No.
No.
They have their own copies. This is wrong. They both have to point to the same location, either 444 or 222. When producer adds anything, it should reflect in the same place where consumer is connected to as well. If there is one object in the memory between the producer and consumer, then it is sharing properly. So whatever changes you do through consumer or producer, it reflects to both of them. They both can see the changes. To do that, you shouldn't have inventory object initialized in both producer and consumer. You shouldn't do this. Okay, when you do this with no initialization, if you say new and new, a new object for this personal copy and a new object for this personal copy, they both have their own different copies. So they both are out of sync. They're not synchronized. They are out of sync. So when you don't initialize them, this is what happens in the memory. Okay, when you don't initialize them, this is what happens. It is null. And inventory is also null for producer. They both are null because you haven't initialized, isn't it?
Yes,
Yes,
sir.
they both are null. They don't have their own inventory copies. Now what I can do is I will create one common object between them. Okay, let's see. On the third line, when I say I equals INV, this is what happens. In the location of INV, a new object is created. And this inventory object will have the stock as 10. That's what this new inventory object did. Okay, it created a new object in the memory and it has 10. Now prod dot inventory equals INV. On the right hand side, what is the value of INV?
Reference 888.
Reference 888. INV value is 888. That is on the right hand side. So hashtag 888 is copied on the left hand side. What is on the left hand side?
Prod.inventory. So
Prod.inventory. We have
8.
now
Count.inventory.
what will this line do?
Put in the same 888.
Will point to 888.
Now the consumer inventory copy is pointing to 888, this one object. Producer's inventory copy is also pointing to 888. Are they both pointing to one object or two individual copies now?
One.
One object.
One object. Okay. So this time when the prod producer adds inventory, okay, it adds inventory to 10. Where will the 10 and 10 quantity be incremented?
On the 888.
888.
When the consumer does inventory, okay, orders 5 items, where will it be decremented from?
Same place.
So now they are in sync. Let's see the output. We don't declare them. We just create one copy, one new copy among them. Okay. So prod.inventory equals inv and con.inventory equals inv. So there is only one copy of the object in the entire application. Okay, only one copy among them. There's only one place where we wrote new. And that same object is shared or pointed by both of them. Now let's see if consumer will display 15 or 5. You got the point, right? How to share an object between two classes? Yes?
Yes, sir.
Yes, sir.
All right, so they both have same copy. So whatever producer increments, it will increment here. Whatever consumer decrements, it will decrement from whatever producer updated previously. So it was not 10 minus 5. This time it became 20 minus 5. Because before the consumer ordered something, producer actually added 10 more. But both of them were able to see the change because both of them were pointing to the same object in the memory. That's how you achieve this scenario. Two programs sharing the same object between them. Do not initialize this class in producer and consumer. Don't initialize them, just declare. But from outside, you actually create only one object between them and pass the reference right hand side to left hand side. All right, so now that you know this, I'll show you how the producer consumer thread program will look like. Right, so producer and consumer share stock. Are they initialized?
No.
No, they are just declared, just like what we did previously. So from the main method, what we are going to do is
initialize it.
right, we'll initialize one copy between producer and consumer and pass that one copy to producer and consumer. So this one new stock object will be shared by both the classes, producer and consumer class. The same thing that I showed you earlier. Rather than initializing in different places in both the threads, we do it in one place, and that reference variable is what we pass it to producer and consumer both. Okay. All right, so let's look at the traditional producer consumer scenario. A perfect balance between producer and consumer is something like this. You have 10 iPhones in stock. Okay, you have 10 phones in stock. The rule is producer should not endlessly keep producing. Okay, think about anything. If you're running a store, are you going to stock up your store every single day, or only when you're about to run out of stock?
Run out of stock.
Only when you're about to run out of stock. If there are no customers coming to your store, do you still keep producing or buying things from your supplier?
No.
No, you'd wait until whatever stock you have is done. So that's the rule here. Producer cannot endlessly keep producing, and consumers cannot buy something if you're out of stock. So that perfect balance should be maintained. Okay, so here is how wait and notify works. Stock is 10. Customer wants to buy 5 iPhones. Can they buy it?
Yeah.
Yes.
Yes. Stock is 10. They want to buy 5. Perfectly fine. So what is the new stock?
5.
Customer wants to buy 3.
Good.
Customer wants to buy 4.
No.
Now here is a question. If there are 2 phones in the stock and you need 4, what is your next action? What do you do?
Restock it.
Produce.
Produce.
You remind the producer, you remind the store owner that you need 4 and you just have 2. Why don't you produce? Don't you say that? Do you just wait endlessly, or do you talk to some representative saying, I need 4, there are just 2? What will you do? Don't you approach someone?
Yeah. Get some more phone.
That's what we call notify. You notify someone that you're running out of stock. Okay, you're running out of stock. You notify the producer. When you notify the producer, what do you do next?
Wait.
You wait. Okay, so this is what happens. When you notify, producer by default is sitting idle. When the whole process starts, producer is sitting idle. Why is the producer sitting idle? Because you haven't run out of stock yet. Only when you run out of stock, then you get into action and you begin restocking. So to begin with, producer is always in wait. Consumer keeps buying 5, 3, 4. When you say notify, what will the producer do?
Start producing.
Yes, it will come out of the idle stage, it will wake up and produce. Okay, now let's say producer has added 10 more quantity. What will be the new stock?
12.
Once you produce, what do you do?
Ship it.
Ship it to stock.
Do you just wait?
Notify the consumer.
Yes, you notify the consumer. So when you notify, what happens? You come out of this idle mode. You come out of the wait mode
Consumer wakes up.
and buy that 4 phones that you were looking for. So what will the producer do after notify?
Sleep.
Wait.
It will go in wait mode. So you see, this notify and wait goes in tandem. Okay, consumer notifies producer and goes in a wait mode. Producer wakes up, produces, they will notify the consumer and again go in wait mode. They will wait until you again run out of stock. This cycle keeps on going forever. Okay, you wake up after the producer notifies you. The stock will become 8. Now, buy 3 iPhones. Do you have to notify, wait, or anything?
No.
Buy 4 items.
No.
Feel good.
Buy 2.
Notify.
You notify. And what does consumer do after they notify?
Wait.
Go in wait mode. So when you notify, what does producer do?
Wakes
Wait.
up.
Wake up and produce. Add default 10. You produce 10 items. What do you do next?
You notify.
Notify the consumer. And what do you do? Notify.
Wait.
You wait. Once you notify, whatever the backlog, buy 2. This was in out of stock order. 1 became 11 after producer added 10. Now here, after notify and wait, producer will notify you back. And what do? You wake up and you continue with your previous order, that is buy 2. 11 becomes 9. This is a perfect balance. You will never overproduce, and you will never buy anything that doesn't exist. If you're out of stock, how can you buy something that doesn't exist? Only 2 iPhone exist. Can you buy 4? You cannot. So you notify producer, and you yourself go in wait mode. The producer produces, notifies the customer, and producer himself will go in wait mode. This is a perfect balance. Everything is happening around which object?
Stock.
Around the stock object. You are basically doing this wait and notify to the stock object. So when you say notify, does the producer exclusively notifying consumer?
No.
No, that's the trick. Okay, everything happens on the stock. Okay, it's like a subscription basis. So when you say notify, what you say is whoever is waiting on the stock object, notify that person. Consumer does not know who is the other person that is waiting. It's a blank screen. Do you know the every individual person who is actually manufacturing the iPhone?
No.
You don't. You just say, I need more phones. Do something about it. You notify the store owner. They are not manufacturing them. There is someone else. Does the manufacturer, the engineer who is putting together your iPhone, does he know which consumer this phone ends up with? They don't. Producer doesn't know exactly who they're talking to. Consumer doesn't know who they're talking to. But both of you are referring to one common denominator, the stock object. So when you say notify, you don't say notify producer object directly. You say stock object notify. So when you say stock object dot notify, every other person who is waiting on stock object will wake up. Okay. So when the producer says notify, if there are 2 customers who are waiting for the stock, everyone will get notified. Not just one customer, but every customer who is waiting on this shared object will get notified. That's how wait and notify works. You do not directly talk to the other person. you basically wait and notify on the shared object that is stock. Okay. So it's like a subscription. When you subscribe to one of the YouTube channel, does the YouTube team individually send emails to every customer, or as soon as they upload, everyone who subscribed gets a notification?
Yeah, as soon as this.
Everyone gets
new-
notification, whoever subscribed, didn't they?
Yeah.
That's how the wait and notify works. Okay, in the program as well. When you say wait, you're not waiting for producer. You're waiting on a new video to be uploaded, or a new iPhone is added to the stock. When you say notify, who are you notifying? Whoever who is responsible for producing stock. Okay, remember, consumer program does not talk to producer. They are talking to this shared object. So when you say notify, you're notifying all the other program that are waiting on stock. When you say wait, you're not waiting for producer. You're waiting for the stock object to be updated. That's what you need to remember. Okay. So let's look at the program now. We have a producer, we have a consumer. My CPU is really slow. I don't know why. GoToMeeting is eating maximum of my CPU. All right. Okay, consumer in an infinite loop is ordering how many items?
3.
3. Producer in an infinite loop is updating the stock with how many items?
10.
10. Okay. So consumer will infinitely order 3, and producer will infinitely order 10. Okay. So this is what you do. The synchronized keyword. Both your actions, producer and consumer actions, are revolving around a shared object, that is stock. So when you produce and consume, what exactly are you synchronizing on?
Stock.
Stock object. Yes. Okay. You have to synchronize your actions on the shared object. Every time producer produces, you want all the other people who are waiting for a new video to be uploaded or new iPhone to be ordered, they all get notified. So you are basically synchronizing on this common topic, which is stock. And hence, here I say synchronized demand. So what is the demand object data type?
Stock.
It's stock. In the producer program, I'm synchronizing on a variable called supply. What is the data type of supply?
Stock.
Stock. They both are synchronizing their activity on the same stock object that we gave to them. The same stock object which we shared with producer and consumer is now being synchronized with. Okay, that's what this first line is. So in synchronized, the logic that we have is consumer will check. If the quantity is less than my order, what do I do?
Wait.
I want to buy 4. If my order is less than the quantity, what do I do next?
Notify and wait.
Notify and wait. You notify and wait on what?
Stock.
On the stock object. Exactly. So if the quantity, that is demand object stock, if quantity is less than order, what do? I notify and wait on stock. The same thing that we did in spreadsheet is right in front of you. Okay. To keep it simple, I'll just write a straightforward. Okay, if you guys are confused with the two different variable names, I can change them to stock for your understanding. Variable name can be different, but they are pointing to the same object in the memory. Remember that. Okay, it's a very simple code. The exact same thing that we learned, that we decided our logic will be, how the real world works. The exact same thing we replicated in our program. I'm going to order 3 in multiples of 3 in an infinite loop. I'm going to synchronize my action. Consumer will synchronize its action on the stock object, and so does the producer will also synchronize its action on the stock object. Okay, so here is what will write our code. Okay, consumer is checking. If the quantity is less than order, notify and wait. So if the quantity is less than the stock, notify and wait. That's all. If the quantity is not less than order, what do?
Decrease from the
quantity. Exactly. Okay, so if you have enough stock, you just keep buying. No need to wait and notify. Only if you are running out of stock, then you notify and wait. How about the producer? You begin with the wait. If someone notifies you, what is the first thing you do after you wake up?
restock,
Add 10 quantity, produce 10, and then
notify and wait.
Notify and wait. So in the producer synchronized block, I'm adding 10 quantity, I'm notifying and waiting. This is what it does infinitely. Produce 10, notify, wait. Produce 10, notify, wait. Wait until someone else notifies you. Produce, notify, wait. Produce, notify, wait. Produce, notify, wait. That's all it does. It will keep waiting until the other person notifies. The same code goes here. In infinite loop, you will check if your order is less than the available quantity. Okay, if it is, then you notify and wait. If there is enough quantity, then you just deduct that from your quantity. It's a 3-line simple code that we wrote based on our analysis on how to balance this producer consumer example. Okay, in both the cases, you are working on the same shared object. The same shared object is being exchanged between both of you, both the threads. One stock object between them, between producer and the consumer class. All right, so let's see if this program gives the right output. You should never overproduce. That's the rule. Okay, you should never endlessly keep producing, and you should never endlessly keep buying, even if you're running out of stock. So the software should be in perfect balance. If you're out of stock, producer should be notified and they will add more. So the stock should never go out of control. Like it should never go to 100 or 200. It should always be between 1 or 0 and 20. Okay, the rule is your stock quantity should always be between 0 and 20. You should never exceed that 0 and 20. Okay, and you should never go in negative either. You cannot accept an order when you're out of stock, isn't it? You should never go in negative orders, and the number should never exceed in 20. So that's the limit. If you stay between this lane 0 to 20, meaning your producer consumer is in perfect balance. Remember that. Okay. See, look at the total stocks. Make sure your total stock never goes in negative and never crosses 20. Did it ever go in negative?
No.
Did it ever cross 20?
No.
So that's a perfect balance. When you run out of stock, you notify the producer. Okay, the stock is 2 and you need 3 of them. Producer produces and notifies back to consumer. From 2 total stock 2, you add 10 more, it becomes 12. So you notify consumer, consumer will order from 12 minus 3 becomes 9, minus 3 becomes 6, minus 3 becomes 3, minus 3 becomes 0. So when your stock is 0, you cannot order another 3. So you notify the producer. Consumer adds 10 phones. 0 plus 10, the new stock is 10. So they both are playing this wait and notify game in a perfect balance. No one is overproducing and no one is ordering items when you're out of stock. The total stock never goes in negative, never goes beyond a threshold. That is wait and notify. Okay, and here is the program for that. Consumer, producer. Whenever 2 threads, okay, just remember this part. If there are 2 programs, 2 thread programs that share the same object, okay, if there are 2 programs that share the same object and you want to synchronize your activity, okay, you want to play this producer consumer game, that is, you want to share the quantity between both of the programs. The first rule is every time you make a change, anytime you make a change, you have to put that code inside a synchronized block. Okay, anytime you make changes, producer makes changes to the stock object by adding 10. Consumer makes changes to the stock object by reducing by 3. Okay, both of them are making changes to this one shared object. So if 2 threads are making changes to this one shared object, your job is to wrap that code inside a synchronized block. This is what we call synchronization. This program will wait until the other program notifies you. This program will wait until the other program notifies you. This is in perfect balance. This one notifies, other program gets notified, wakes up, does their job. This one notifies, the other program will come out of the wait stage and start doing this all over again. Order, order. Okay, but any changes you do to the shared object, it should always be inside a synchronized block. Remember, it should be synchronized block because we want to synchronize our activity between 2 programs that share information. Okay.